I am still on page 185. I'm looking at example number 2. And for those of you who do not have the textbook, we will draw these. Tell whether each graph represents a function. So the first one is probably the most basic coordinate graph you can have. The line runs right through origin in a positive slope. So it's something like that. Is this a function? Let's do the vertical line test and see. So there's a vertical line. There's a vertical line. There's a vertical line. And on each one of those, it only touches the red line once. So yes, this is a function. It passes the vertical line test. So yes, it is a function. On a test, this is the best kind of question you can get, as long as you know your best friend, the vertical line test. All right, we have another one to try. So we have this situation, and then we have a function that's coming from, or a graph, that's coming from the origin, and it makes that nice V shape. It looks pretty good, doesn't it? But is it a function? Let's apply the vertical line test and see. It is not a function, because look at this. The green line touches the red one here, and it touches the red one here. So we can say that this one fails the vertical line test. Therefore, it is not a function. Okay. So that brings us to the end of page 185. Let me look at page 186, and let's go ahead and get that equation example up there. So I'm on page 186. This will be example 3. And let me just take a look at it and see what it is I'm supposed to do. Okay. I do want to write this word problem out. I want you to do that as well, so it's in your notes. Suppose every item in a store is priced at $5. Write a function to represent the cost of X items. If you need to pause the video, that's fine to write this down. What is the cost of 4 items? So here's a question. And here's the second question. If someone spent $30, how many items did he buy? So we've laid that theoretical foundation, but now we're being asked to solve a problem using that theoretical foundation. So let's take a look at the story and what we know. Every item in the store is priced at $5. And we want a function to represent the cost of X items. So I'm going to start this one off with something you're familiar with. And that is an input-output table. Okay. So just draw this with me. And let's bring the middle line down. And I'm going to put this in terms that we understand to begin with. So X's and Y's. I'm also going to put this in terms of independent and dependent. So if I walk into the store, the independent variable, the thing that I choose, is how many items I'm going to buy. I can buy one, or I can buy 5 million if I want to. It's up to me how many I will buy. And depending on what I choose, we're going to be looking at dollars. All right? So the dependent variable is the amount of money I'm going to spend. The independent variable is the number of items I'm going to choose. So if I choose one item, how much will I pay? I will pay 5. Okay. Now, I know I've left this space open. Just hang on to that for a minute. And let's focus on that 1 and 5. Remember what slope is. Slope is rise over run, or y over x. So we could say that the slope here is 5. We could say the unit rate is 5 over 1. We could also say that the constant of proportionality is 5. That's the same as slope. But I won't get into that in this example. Let's just use unit rate and slope. Now, if you know the unit rate, you can set up an equation. You can find any number of items that you want to find. So let's go ahead and do that. Let's set up our equation of y equals mx plus b. Remember that formula, slope-intercept. So y is 5. I'm sorry. Yes, y is 5. Slope is 5. X we're going to leave in there. Nope, we're not. We're going to use 1 for x. So b is about to be found here. We're going to say 5 equals 5 plus b. Minus 5 minus 5 is 0. So b is 0. There is no intercept to consider here. So my formula, my function, is going to be y equals mx plus b. And we just said that b is nothing. We just said that slope is 5, and there is the x. So that simplifies to this. This is the function right there. Now, once you have that function, you can write any equation that you need to find a value. So, if y equals 5x, what if x is 4? So that would be 5 times 4 is 20. So if x is 4, y is 20. What if y is 30? That means x is 6. Okay, so once you get the function, the rule that applies to this problem, you can put in any input you want and get the answer you're looking for. This is what we did in Chapter 5. Nothing's different here. Now, I'm about to give you function notation, but it's okay. It won't matter. This is the same concept that you did in Chapter 5. It's just in this chapter, we're using an x and an f of x. So I'm going to rewrite the function, the same thing. Instead of y equals 5x, I'm going to say f of x equals 5x. And then I'm going to tell you that when x is 1, y, the output, is 5 times 1, which is 5. When x becomes 4, 5 times 4 is 20. When this is 30, 5 times x, we solve for x, and x is 6. It is the same math. It's just a different notation. This is in function notation, and the x's and y's are just in regular standard xy notation. So we're doing exactly the same thing. We're just labeling it a little bit differently. And we're going to be doing a lot more of this. So to answer the questions, what is the cost of 4 items? When x is 4, f of x is 20. If someone spent $30, that means he bought 6 items. Okay, that's a good high set question. That is not easy stuff. But it is the same stuff that we've been doing now for a while. And I'm going to move that so that that thing is what goes up there.